Okay, in the last video we learned how Hess's law works. And Hess's law is the idea of taking, you have an unknown equation and you're trying to solve for its delta H. In this problem we're going to be solving for this one. But the way it worked was you were given related equations and you just had to manipulate things until you got to the unknown equation. This is a different process, but it gives you the same result. Either answer works, it mostly just depends on what you have available to work with. Okay, to do this, we're going to use Appendix C, which I will put on OnCourse, but this is, most textbooks, in the appendix in the back, Appendix C is always the one for enthalpies of formation. Okay, this is delta H for reactions that are basically how much energy it would take to form this from pure elements, not from other compounds. That's what the F stands for formation. This stands for standard conditions. So basically this would be at like 298 Kelvin or 25 degrees Celsius. Okay. So literally all you do is you just take the products minus the reactants. That's literally the entire process. Okay. So what we need to do is we need to know what are all the delta H of formation for each of these. So we're going to use Appendix C. Okay, this may not be the one that I post on OnCourse, but it's from a different textbook. State symbols matter a lot. So the first one we're looking for is zinc solid. And there's delta H, delta G, and delta S. We only care about delta H right now. Next semester we'll care about the other two. Right now, zinc delta H is 0. Super easy. Sorry for the moving camera here. Okay, now we need HCl gas. Actually, since I'm already in this part of the book, I'm going to look up ZnCl2 solid. It's all in alphabetical order. So, ZnCl2 solid is negative 415.1. Okay. Now we're going to look up HCl and H2. Tables are a few pages long, it's not a big deal. Okay, for HCl, it is a gas on our chart, so negative 92.31. Okay, and then H2 gas, which is probably near the top. H2 gas is another 0, so that's okay. Kind of makes our lives easier, actually. So we know each of the individual values. I'm gonna try to put this back. Okay, so now what we're going to do is we're going to take the products times the reactants. The coefficients in the front do matter, so when we get to this one, since there's a 2 in the front, we will need to double this. But literally we're just adding up the products minus all the reactants. And be careful with the negative signs because they can mess things up. So these are the products. So negative 415.1 kilojoules plus, well, 0 doesn't change anything, but I'm going to write it down just so you can see where the numbers are coming from. So these are the products. And then you could add up the reactants and then subtract it. It's almost easier just to subtract each of them. So minus 0 kilojoules for this, and then minus 2 times negative 92.31. Okay, so these are the reactants. Okay. Literally you just add it all up. So take negative 415.1 plus 0 minus 0, that doesn't affect anything, minus 2 times negative 92.31. Okay, and I guess it's all addition and subtraction. This has 1 decimal, this has 2, so 1 decimal is the right answer. So delta H for this is negative 230.5 kilojoules. Okay, so essentially we have an unknown equation we're trying to solve for delta H. This isn't, I actually think these are easier than the Hess's law problems, but honestly it kind of depends on what you have access to. So if on a quiz, if I give you Appendix C, you do it this way. If I give you the multiple balanced equations like we saw last time, you have to do Hess's law. So and unfortunately, I need you to be good at both, even if one seems easier than the other, because in the real world, you never know which one you're going to get. I guess that's it for that one. Cool. Thank you.